Welcome to Pure Mathematics 1, Chapter 5, Differentiation. Topic, maximum and minimum points, and the second derivative. So why I combine these two topics in one video? Because the main use of the second derivative is used to identify whether which stationary point is a maximum point and which one is a minimum point. So in order to create a logical linkage between the two topics, I want to combine them in one video. So the next part, we would start with the minimum and maximum point. So if you have a curve like this, you have a curve like this one. This one is called the maximum point. The maximum point, and this one is called the minimum point. Minimum point. And here, these two are both called the stationary point. Stationary point. Maximum point and minimum point, both of them are both stationary point, and their dy over dx equal to 0. So in order to identify whether a point is a maximum or minimum point, we would find the dy over dx. If the dy over dx equal to 0, that point can be either a maximum point or minimum point. You can look at this one, these two graphs. The first one from the first one we can see that before we can see a maximum point, there will be a positive gradient up here, and then at the maximum point, the gradient equal to 0. And after the maximum point, there will be a negative gradient. But for a minimum point, before a minimum point is a negative gradient. Which one is going down? And at the minimum point, it is a gradient which is equal to 0. And after the minimum point, the gradient will be positive. It's going up, like this one. So these are the basic knowledge related to minimum point and maximum point. And now I have an example. Find the stationary point. Stationary point of y equal to x cubed minus 3x plus 5. So first of all, we need to find the dy over dx equal to this one, 3x squared minus 3. So they are stationary point, so this one will be equal to 0. So we have 3 multiplied by x squared minus 1 equal to 0. So we have x minus 1 multiplied by x plus 1 equal to 0. So we have x equal to 1 or x equal to minus 1. So these are the 2 points. One of them is a maximum point and one of them is a minimum point. And now we don't know how to determine which one is a maximum point and which one is a minimum point. In the textbook, they provide a method to determine which one is a maximum point and a minimum point, but I think that way is quite long and time consuming to do, so I would use the next part of the video to introduce the second derivative to help you guys to have a quicker way to solve and to determine which one is a minimum point and a maximum point. And now we will talk about the second derivative. So we all know that dy over dx is called the first derivative. The first derivative. So if we differentiate dy over dx, we will get the second derivative. Let's say I have the equation y equal to 2x cubed plus 3x squared minus 12x. So my dy over dx will be equal to 6x squared plus 6x plus 12. And then I don't stop here. I differentiate this one a second time. So I get, so the notation for the second derivative is that d squared y over dx squared equal to, now I differentiate this one. I have 12x plus 6. So this one is called the second derivative. Don't be confused between d squared y over dx squared with this one, dy over dx squared. They're not the same. They are not the same because this one did represent this one square, but this one represent the second derivative, and we differentiate the first derivative to get the second derivative. So y, we can use the second derivative to determine which point is minimum point and which point is the maximum point. So from the graph, you can see that the point P is the maximum point and the point Q is the minimum point. This one is plot y against x, but now I convert it to another one, which is the dy, so dx against x. So we can see that in here, the gradients of P and Q are 0, but then when you convert into the graph of dy over dx against x, you will have the gradients of the maximum point is this line, and you have the gradients of the minimum point, which is this line. Here's a negative gradient and here's a positive gradient. So from here we can say that if d squared y over dx squared greater than 0, which is this one, that one is a minimum point. But if the d squared y over dx squared smaller than 0, that one will be a maximum point. So from here, we cut the graph of dy over dx against x will have the gradient be this one because we differentiate dy over dx with respect to x for the second time. So we have d squared y over dx squared. Remember this rule? So we can use this rule to determine whether a point is a maximum point or a minimum point. Now we will work with the example that we took from the previous section, which is y equal to 2x cubed plus 3x squared minus 12x. And now we have dy over dx equal to 6x squared plus 6x minus 12. So in order to find stationary points of this one, we would equate this one equal to 0. So we have 6 multiplied by x squared plus x minus 2 equal to 0. So from here we have x squared plus x minus 2 equal to 0. So x squared minus x plus 2x minus 2 equal to 0. So x multiplied by x minus 1 plus 2 multiplied by x minus 1 equal to 0. So x plus 2 multiplied by x minus 1 equal to 0. So we have two possible values, x equal to minus 2 and x equal to 1. So now we will determine which one is the maximum point and which one will be the minimum point. First we find the second derivative of the equation, d squared y over dx squared equal to, we differentiate this one equal to 12x plus 6 when x equal to minus 2. So d squared y over dx squared equal to minus 2 multiplied by 12 plus 6 would be minus 18, smaller than 0, will be the maximum point. Maximum point d squared y over dx squared when x equal to 1 equal to 12 plus 6 equal to 18, which is greater than 0. So this one will be a minimum point.